Hello, in this video we'll go over kinematics in two dimension, also called projectile motion. You will learn how to solve problems where objects are thrown at a certain angle with a certain velocity, and we need to calculate things like distance, velocity, time, and acceleration for them. In the first 5 minutes, we'll go over all the equations you need to know and all the keywords that you need to keep in mind when solving these problems. We will also learn a step-by-step instructions on how to approach any problem in this unit. And in the last 5 to 7 minutes, we'll look over two very representative, very common problems that you must know if you want to do well on your upcoming test or quiz. Let's firstly start by examining the equations that we have in this unit. So in total, we only have 5 variables: initial velocity, measured with units of meters per second, final velocity, acceleration, displacement, and time. When our motion is constant velocity, that is, our acceleration is 0, we just use this one equation right here. In the two-dimensional motion, that is when we think about the motion in the horizontal direction and vertical direction, we only have acceleration in the vertical direction, right? Because our acceleration is acceleration due to gravity. That is, accelerated motion will happen in the y direction and non-accelerated motion will happen in the x direction. So we'll talk about this in a little bit more detail, but this equation we'll use in the x, this 4 equations we'll use in the y. And how do we know which equation to pick? So the method is very straightforward. These 4 equations are just different ways to arrange these 5 variables here. So based on the variable we don't care about, we'll pick one of the equations. For example, if displacement is a variable that you're not given and you don't need to find it, so we call it a variable you don't care about, you'll pick the first equation. If a variable you don't care about is the final velocity, you'll pick the second equation. If it's the time, we'll pick the third, and if the acceleration, then we'll pick the fourth. Now, let's also take a look at the keywords that we need to keep in mind as we're setting up these problems. So, when you read the problem, I want you to be able to identify these keywords. If the problem says starting from rest, that means initial velocity is 0, right? At first, the object is not moving. If the problem says coming to rest or coming to stop, that means that final velocity is 0. If we're saying that velocity is constant, that means acceleration is 0, although that will not be the case for these types of problems. If something is dropped, usually velocity is also 0. Now, something really important happens at the maximum height. At the maximum height, when you throw, let's say, a stone in the air, for a brief moment, it stops at the highest moment, right? Before it goes down again. So at the maximum height, velocity is 0. But notice that is the y component of the velocity that is 0. Oh, and also our acceleration in all of these problems is negative 9.8 meters per second squared, because we're dealing with objects that are only experiencing acceleration due to gravity. So this you can always write for y. Now, one more thing I would add to this is a phrase thrown horizontally. Because if something is thrown horizontally, that means it only has the velocity in the x and its initial velocity in the y is 0. So if you know these keywords and you know the equations and how to pick the right equations on the previous page, you should be really good at solving these problems. Let's take a look about what our general approach will be for solving these. So the first thing, if the velocity is at the angle, which in a lot of these cases it will be, we need to find the x and the y component. Guys, this will always be our approach if we have any quantity at an angle. We always have to find the x and y component of our vectors. Always, 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 that will be the first step if something is at the angle. Then you set up this table right here. That's what I would recommend, is the easiest way to solve these types of problems. So in the x direction horizontal, we have non-accelerated motion, as we talked about. So you just write down delta x, v, and t, those variables, and write down what you're given. In the y direction, right, this is going to be accelerated motion. So we'll use those 4 equations. We'll have to pick between them. And you can write down all the 5 variables in total that you're given and write down what you're given. So some of them might be given as strictly numbers. Some of them might be given as those keywords right there. So you need to be able to identify the keywords as well. So we'll mark the, let's say we'll have 3 variables that are known. We'll mark the unknown, and we will cross out, let's say, a variable that we don't care about. And based on the variable we don't care about, we will choose the appropriate equation and solve for the unknown. This setup right here, I would say it's 80% of solving the problem. If you make sure that you set up this table correctly, the rest of the problem will flow pretty easily. Now that we know this method, let's apply it to our first practice problem on the next page. So, projectile launched horizontally. So we have a ball here. Firstly, I will sketch the problem. That is rolled off with a horizontal velocity of 3 meters per second. The table is 1.2 meters high. And we have to calculate how long it takes for the ball to hit the ground and how far from the base of the table the ball lands. So I sketched the problem. My velocity is not at the angle, so I don't have to find its x and y components. It basically only has an x component, right? Because it's to the right. So number 1 step is completed. The second step is, of course, to make the table. So in the x direction, I just have 3 variables, and my velocity, right, is going to be in the x direction, so 3 meters per second. In the y direction, I have 5 variables: initial, final velocity, acceleration, time, and delta y. By the way, you don't have to memorize these because, again, you will have all your tests, you will have be presented equations, so you can just read off what these variables are. Okay, let's think. What is the initial velocity in y? Are we given it? Well, although we're not given it directly, notice when it says thrown horizontally, it's one of those keywords, which means that initial velocity in y is 0. And it's 0, right, because the initial velocity is only vertical. So we have that. What we always have is that acceleration is negative 9.8 meters per second squared. What we need to calculate is the time, question mark. And what about 1.2 meters? 1.2 meters is a vertical distance, so it will go in the y instead of x. So right here, we have 3 variables, and we always need 3 variables to solve for the 4th one in the y direction. The variable we don't care about in this context is final velocity. So based on the variable I don't care about, which is the final velocity, I will pick the second equation right here. Delta x, or in this case, delta y, is initial velocity times time plus 1/2 at squared. The only thing that's left is just to plug in all the quantities. Let's see, initial velocity is 0. Therefore, this term right here, 0 times t, will cancel out. And it's just going to be delta y is equal to 1/2 at squared. Let me rearrange this equation for time. So I will multiply both sides by delta y. I will divide both sides by acceleration. And then I will take a square root of both sides to find what the time is. So here we'll cancel out. So it's 2 times negative 1.2. Sorry, the displacement should be negative because we're traveling downwards 1.2 meters. Remember, displacement is a vector, which means it can have a positive or a negative direction. So the fact that it's going down 1.2 meters means that it's negative 1.2. And acceleration is also pointed downwards, so it's minus 9.2 meters per second. And if we plug all of that in, we get an answer of 0.5 seconds. All right, so that is part A. Now the second question is, how far from the base of the table the ball lands? So now that we know time is something that is the same, right, in both y and x. So we can fill out this table, this part right here, 0.5 seconds. So to solve for delta x, we can just use the equation for constant velocity, which is delta x is equal to velocity times time. By the way, if you're not given this equation, don't worry, because if you take a look, for example, at the second equation, right? When the acceleration is 0, this term right here cancels out. Therefore, you can see that this is an equation for the constant velocity, right? In case you're not given it explicitly on your formula sheet, right? You can take a look at one of these and derive this pretty easily. Okay, now we just need to plug this in. Our velocity in x was 3 meters, our time was 0.5, so the total distance is 1.5 meters. All right, this was our problem 1, a projectile launched horizontally. In the next problem, we will take a look about what happens when a projectile is launched at an angle, a very important problem that you must know before your test. Let's take a look at it. In problem 2, a projectile is launched horizontally at an angle of 35 degrees and a velocity of 25 meters per second. We need to calculate the maximum height that is reached by this javelin, delta y. Okay, so first step is sketch the problem. If the velocity is at the angle, we will always find the x and the y component. So let's do that first. We can use SOHCAHTOA, sine of 35. So means sine is opposite over the hypotenuse. So the opposite side is y, and the hypotenuse is 25. So Vy over 25, which means Vy is equal to 25 times sine of 35. Now we can also write down the same expression for cosine of 35 is equal to Vx over 25, and multiply both sides by 25. Vx is equal to 25 times cosine of 35. Once we plug those in the calculator, the first one will give you 14.4 meters per second, and the second one will be 20.5 meters per second. So that is the information that will go into our table. The second step is, of course, to set up the table in the x and the y direction. In the x, we just have 3 variables, and in the y is the initial velocity, final velocity, acceleration, time, and displacement. In the y acceleration, always will be negative 9.8 meters per second squared. Now let's plug in the velocities that we just found. This is the initial velocity in y, 14.4. And this is the initial velocity in x, 20.5 meters per second. Okay, let's see, anything else that we know? So remember that we need to always have 3 variables in order to solve for the fourth one. So in this case, we're given only 2 variables. So there must be some kind of keyword that we can use in order to get the third variable. They are asking for the maximum height. So what happens at the maximum height is that the Vy is equal to 0, right? Because you go from going upwards to going downwards. So essentially you have to stop for a second before going downwards. So final velocity here is equal to 0. And that's something we got from keyword. The maximum height, we need to find delta y. So for now, the variable we don't care about is time. Let's take a look at our equations right here. If we don't care about time, we should pick the third equation right here. Final velocity squared is equal to initial velocity plus 2a delta x. Now, or we can call this delta y, right? Because it's the displacement in the y direction. So let me subtract initial velocity squared from both sides. Then divide 2a on both sides. Now, the only thing that's left is just to actually plug this in. So final velocity is 0. So it's going to be 0 minus initial velocity squared over 2 times negative 9.8, which equals to 10.43 meters. So guys, as you see, the most important part is to set up these problems and then know the overall process, right? If you know the step-by-step instructions, these problems become really simple. Okay, Number part B, the total time the javelin stays in the air before hitting the ground. So now we do care about the time. So let's calculate the time first of all. Before calculating the total time, let's just calculate the time that it takes to go to this maximum height. We can really use any equation now because we know 4 variables, right? But let's use, for example, the simplest one is to use the first one. Final velocity is equal to initial plus AT. So final velocity is 0. Initial velocity was 14.4. This is negative 9.8 t. So if we rearrange this, so we subtract negative 14.4 on both sides and divide negative 9.8. So time is equal to 1.46 seconds. Now, notice that this is the time that it takes to reach the maximum height. So the total time is just going to be twice that because the second half of the journey is going to take just as long as the first half. So our answer, you can just multiply it by 2 and get 2.91 seconds as our final answer for the total time in the air. Okay, now finally, let's solve for part C. Once again, time is something that is the same in both x and y. So notice once we found it, we can put it in both x and y. So we can find delta x now the same way we did in the previous problem. So delta x is equal to v times t, or is equal to our x velocity was 20.5 times 2.91, which is equal to 59.8 meters. So guys, hopefully this made sense. You can always feel free to scroll back and watch how we solved some of these problems. In the next video, we will take a look at one more example of a little bit more complex, but also extremely common problem in this unit. So keep practicing and thank you for watching.